Bismillahirrahmanirrahim. In this lab, we are going to use switch statement with Arduino. So, what is a switch statement? In C language, a switch statement, what it basically do is compare values. It's a way to decide which statement is going to be executed next. Based on a given input, it will compare that with a set value and decide the part of the code that is going to execute. It must be an exact match. In each statement, there is a value and list of statements. The flow of data, the flow of control transfers to a statement is associated with the first case value that matches. So in case there are more than one value received, it will execute the first one first, and so on. The syntax of switch statement is that there is a switch bracket expression. Okay. So the input value or the value expected by the program, the argument, is compared here, and there's cases. So based on the value that is received, or the words or the bytes, it will switch to that case, which means that if the expression matches value 3, it will jump to case value 3. And there is a break statement. The break statement can be used as the last statement in each case, which means that a break indicates that this is the end for that case. The break, it seizes the statement, it stops the statement and gives control back to switch. So switch can compare the next value. If a break statement is not used, the flow of control will go to the next case, which means that without the break, after case 1 is executed, it will go to case 2, then it will go to case 3, and so on. Or if the expression in switch statement received is value 2, so it will start with case 2, then case 3, and so on. However, by putting a break, it means that when that case is finished, it will go to default, or it means that it will not execute the next case. For example, we have a switch, then there's an option. The option is expecting letters A, B, and C. So if I enter A, it will run code under case A, and then it will skip the remaining cases because we have a break. Without a break, it will go to case B, then case C, then exit. Here's another example. On the right, we have a piece of code without breaks. So if A is sent to the program, it will run the code for A, then B, and C. So the direction of execution of code is sequential. On the left side of code, because of the break that we have here, it will go from case A, and after the code is finished, it will exit. It will skip the remaining cases. In switch statement, there is also a default case. Default case is not associated with any value. That's why we use the reserved word default. It means that any input that is sent to a program which is not mentioned in the cases will go to default. For example, switch with default case will look like this. So we have options A, B, C, and we have default. Now if I enter the letter A, it will run this part of code for B and C respectively. Those codes will run. However, if I enter letter R, what will happen? It will run the default case, the default code. For any letter that is received with a program which is not A, B and C, it will run default. So to switch or not to switch for the program, the expression of the switch statement must be result in integral type, meaning an integer. Could be a byte, an integer, a long integer, a character. It cannot be a Boolean expression or a floating value. Okay? You cannot use for switch, we cannot use a float or a double. The implicit Boolean condition in a switch statement is equality, which means that you cannot perform relational checks within a switch statement. The flow chart for switch statement is, there's an expression, and depending on the case which matches the expression, it will run case 1 or case 2 or case 3, or it will go to default if nothing matches. Let's see an example. I have this code. It's a C code, and I would like you to try this in your compiler. The program is a C++ code. The program is expecting letters A, B, C, D and F, and based on what we enter, it will give the number value in terms of GPA for A, B, C, D and F. Let's try this. Here I have the same code which I show you in slides in C++. I'm going to run this code and see what happens. So in my first run, I'm going to enter for case C and see what happens. So it's asking me to enter a grade A, B, C, D and F. Let's say I enter C. It shows me the GPA for C. What will happen if I enter C in small letters? Let's say I enter C small. Invalid grade, because this was given in my default. The default is it will give me invalid grade, and after the statements it's going to show me the grade is the number I enter or the character I enter. If I enter F, it's working fine. So we observed this code in C++. I was using Turbo C 4.5. You may try this code in your version of C. Obviously, based on compiler, there may be slight changes in the code, but you know what to do. Here's an example. Here's a quiz. Write a code using case to show the multiplication tables up to 10th digit for number 1 to 5. It should ask me to input a number, and based on my number 1 to 5, it should show me an output like this: 2 times 1 equal 2, 2 times 2 equal 4, and so on. Any number other than 1 to 5 should display some message. Can you try this? Try this and see the output. Let's talk about microcontroller, our main topic. I want to implement case statements in microcontroller. I'm going to use Arduino Uno board, and I'm going to use serial read to enter the numbers, enter some characters that will turn on LEDs connected to pin number 2 up to 6. So first, on my board I'm going to connect the positive side of LED of 5 LEDs to pin number 2, 3, 4, 5 and 6, and cathodes of LED on the negative side will go to ground. I'm going to design a sketch that will take the code that will read the inputs A up to E to turn on 5 LEDs. Okay, so I will use switch case statements to read those characters serially, and in serial monitor I will send the character and will observe my results on Arduino board. Okay. And we need to draw block diagrams, schematics and flowchart for this problem. So this is how my configuration is going to look like. And on Arduino, well, depending on your LEDs, I mean, you may not use resistors because the LED pin, the Arduino pin gives very low current, and there's enough protection within the circuit on board. So even without the LED, without the resistors, your LED should be safe. So here is my setup. I have connected to pin number 2 the green LED, the red one to pin 3, the other red to pin 4, the yellow one to pin 5, and finally another red to pin number 6. Okay, my circuit is a bit rough, but you know how it goes. And the negative side of, actually this wire is not used, the plus power supply, I am not using it for this project. So there's a common cathode for all of them, and the positive sides of each LED goes to respective pins. So moving on, here's a flow chart for this project. Okay, this little exercise. We'll read the serial data, and the program is going to check if it's a valid case A, case B, case C, case D, and case E, and it's going to turn on those lights. And for invalid options, it will do nothing. Default is all lights will be off. My code will look like this. Okay. Let me share with you the code from the Arduino IDE. Okay, here's my code. Okay. The setup is the part of the code that is going to run only once. I will initialize my serial port at 9600 bps, and I'm using a loop here. Instead of writing pin mode 2 output, pin mode 3 output, pin mode 4 output up to 6, I'm just using a loop. So for this pin, when it's 2 output, then 3 output, 4 output, up to 7. In the loop, okay, this is the part of the program that is going to repeat forever. First of all, is going to check for available serial data. If serial data is there, I'm defining an integer called inbyte. Inbyte is taking the value from serial port, so serial read is inbyte. And then I have my switch statements: case A, case B, case C, D, and E. So, and default is there's a delay of 1 second, and then all the lights are off, which means that if I send A, the light connected to pin 2 is high, and then it will go to default. So it will stay high for 1 second, okay, 1000 milliseconds, and will be off. I'm going to start my serial monitor. I've already uploaded, let's upload this data to Arduino, and then I'm going to open my serial monitor from here, and I will send my code. Let's okay, if I can manage to show you all of them. Okay, here's my Arduino. So I will upload and the serial monitor is here. Okay, so let's see. Now if I enter A, I'm expecting the green light to turn on. So I enter A, and for 1 second it's on. If I enter B, I'm expecting the next one, the red one. C, let's enter D. D will on the yellow one. D. E will on the last one, the red one. F will do nothing. C is going to on the middle one, the red one. Again A. So that's how a switch statement works in this case. I may change my code. Let's say let's put a new case, and that is okay. So that is I will do case I'm going to do case, after case E I'm going to do case, okay, let's copy this, let's call it case X. So when I enter the letter X, what it's going to do is, let's copy this loop from here. This is the part where I turn everything off, and copy it here. So when I enter the letter X, it's going to turn on all LEDs at once. So I'll upload this code, and oh, okay, supposed to happen. Okay, so my code is ready. If I enter A, it does nothing. And why it does nothing? Because I entered capital A. Yes, okay, let's enter small a. Okay, let's enter D. Yes, let's enter X. Oh great. Okay, so yes, okay, so you can modify this code, you can play around in this code and see what else you can do in this. Okay, maybe I can enter the letter, I can enter numbers. Okay, to, like, for example, I can enter number 3 to blink the light 3 times. Okay, shall we try this? Let's try this. Okay, after this one, so let's copy this case X and paste. Okay, I have a special case here. I will call it case let's call it P. Okay, let's see, I have defined a case P, and what I want for P is to blink the lights. So let's say 2 will be high, and make a delay, half a second delay is enough. Okay, not just 2 actually, I want all of them to be high. Three is high, 4, 5, 6. And okay, all of them are high, then there's a half second delay, then I want all of them to be low. So 2, okay, repeat this for 3, 4, 5, 6. All right, and okay, this is one blink for all. Let's put another delay. just one delay. Okay, let's put it in a loop for int k equals 0, k is less than, so 3, okay, 3 is enough, 3 k plus plus. Okay, let's see, let's observe this. So this is case P, break, okay, upload, okay, let's see. A is green, yes, as usual. D is yellow. X is all. And P, now this is our case. Let's see, 2, 3, there you go. So with P we blink all the lights 3 times. Okay, let's do it again. Isn't it fun to watch? 1, 2, 3. D, C, A, L, nothing. So that's how you use switch statements with Arduino, and you may modify this code, you can do something different, and that's it for today. I hope this video was useful. This video is useful for you. And the other thing is, like in previous lab we did something called serial write. So you can send the status of each light from the code by using serial print. Okay, so it will show you on the serial monitor status of the light. So play with this code, do something else, okay, modify it and see what you can do with this. It's Arduino, as I said, it's a fun toy to have. So thank you for watching. Goodbye.